This video is on balancing chemical reactions. So chemical reactions need to be balanced because of the law of conservation of mass. The law of conservation of mass states that mass cannot be created or destroyed. This means that the mass of the products must equal the mass of the reactants. For example, in a closed system, if 5 grams of reactant A are mixed with 3 grams of reactant B, how many total grams of product will they make? Well, this tells us that A is mixed with B. So those are our reactants, so A plus B, and they're going to make or produce something. So we have an arrow and then our question mark for what we're going to make. If I start with 5 grams of A and 3 grams of B, because I cannot create or destroy the mass that I have, that means that at the end I must have a total of 8 grams of products. Just like mass, atoms cannot be created or destroyed. We need to be able to count the atoms that we have in a chemical reaction. When I'm just given the element, like here with sodium, and there's no number after it, I assume that I have 1 sodium atom. Here, I have a 2 after my oxygen. This tells me that I have 2 atoms of oxygen. Here I have a compound. I have an aluminum with a sulfur that are bonded together. This is an ionic compound, and this is aluminum sulfide. If I look here, I have a 2 next to the aluminum and a 3 next to the sulfur. So this means that my aluminum, I have 2 atoms, and for my sulfur, I have 3 atoms. So that means if I were to draw this, I would have an aluminum and 3 sulfurs coming out of my compound. Here, in my fourth example, I have something in parentheses. Just like in math, when I have a number outside of my parentheses, that number distributes in to both things inside my parentheses. So the same thing applies here. I have my aluminum, so I have 1 aluminum. And then I have this NO3. Inside my NO3, I have 3 oxygens and 1 nitrogen. But I have 3 of these. So 3 times my 1N and 3 times my 3 oxygen. So for nitrogens, I have 3, and for oxygens, I have 3 of 3, which means I have 9. This is important because we need to balance chemical reactions. To balance a chemical reaction, we will start at the left, or my reactant side, and work all the way to the right, or my product side. I need to go all the way through my reaction before I go back and check my amounts. I'm going to draw dots or lines to help me count atoms. One thing to note up here, sometimes we have atoms that are 1 element but 2 atoms put together to make our molecule. These have a special name called diatomics, di meaning 2, atomic for atoms. Our special ones that we have are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Everything else, so every other element on the periodic table, likes to be by itself. So we just write them as we see them on the periodic table. So for example, aluminum would just be Al. For every one of your reactions, I will provide you with the chemical formula. You simply need to identify which is a reactant or product and set them in their right locations. Then we will balance our reactions and assign states of matter if we need to. Here, sodium reacts with oxygen to produce sodium oxide. So when I see produce, that tells me where my arrow is going to happen. These two react together, so react means I have my plus, and I'm going to make just one product here, my sodium oxide, which is my Na2O. So this means I have sodium, Na, plus my oxygen, which I see as O2, to produce, yield sign, sodium oxide. Na2O. I know that sodium is a metal, so that's a solid. Oxygen is a gas. And I don't know what this is, but that's okay. Then I'm going to balance my reaction. This is where my dots and lines help me, and I go from the left and then all the way to the right. So here I don't have anything after my sodium, so I have one sodium atom here. I have two oxygens here, so that means 1, 2 oxygens there. I have two sodiums here, because this 2 applies to the thing before it. So 2 sodiums here, and 1 oxygen there. So I see that I don't have the same number of atoms on the left as I do on the right. So I have 1 here, 2 here. So to do that, I need to add in a coefficient. So I put my coefficient in the front, and this means that I now have 2 sodium. So this applies to my whole thing here. So I add another dot here. So now I have 2 sodiums on the left and 2 on the right. I have 2 oxygens on my left and 1 on my right. So I need to multiply this. So I add a 2 in front here, and that applies to both my sodium and it applies to my oxygen. So 2 times 1 gives me now 2 here, and then I have 2 more. It doubles my amount here, so I have 2 more here. So now I take a look and my oxygens are balanced, but when I added this 2, my sodiums aren't balanced anymore. So that means that instead of a 2 here, which I had before, I just had the 1, instead of the 2, I really need to have a 4. So I have 4 times my 1, the imaginary 1 there, 4 sodiums here, 4 here, 2 oxygens, 2 oxygens. So now this is a balanced reaction. Let's do the next one. Here, when sodium metal is placed in aluminum sulfide, it yields, there's my arrow, sodium sulfide and aluminum metal. So when sodium metal Na, so sodium Na, is placed in, so that's my plus sign, aluminum sulfide, it yields, there's my arrow, sodium sulfide and aluminum metal. Here I have just an element by itself, so there's 1 sodium. I have 2 aluminums, and I have 3 sulfurs. On my right, I have 2 sodiums, 1 sulfur, and 1 aluminum. So I go ahead and start with my sodiums. I have 1 sodium here and 2 here. So I'm going to put a 2 in front of my sodium to make this 2. I have 2 aluminums here and 1 here. So I'm going to put a 2 in front, which gives me 2 aluminums. I have 3 sulfurs here and 1 here. So I'm going to multiply 1 times 3 to give me 3. But that also affects my sodium. So remember, this goes to the sulfur, but it also goes to my sodium. So 3 times 2 gives me 6 sodium. So now I go back and check. 2 sodiums, 6 sodiums. Whoops, I need to change that. I had 1 to begin with, so I need to have a 6 in front. So 6 sodiums, 6 sodiums, 2 aluminums, 2 aluminums, 3 sulfurs, 3 sulfurs. Last example. I have water, H2O, and carbon dioxide are made, so that means these are products when dicarbon tetrahydride, C2H4, and oxygen are combusted. So that means these two things are combusted, so this is where they react together. And my water and my carbon dioxide are made. So I'd write C2H4 plus O2, my oxygen, are combusted, so we need to have oxygen present to combust. And we make water, H2O, and carbon dioxide, CO2. So we need to make sure we read carefully so we know what's being made and what's reacting together. So I go ahead and I draw my dots and lines. I have 2 carbons. I have 4 hydrogens. I have 2 oxygens. Here I have 2 hydrogens, 1 oxygen, 1 carbon, and 2 oxygens. So I start on the left. I have 2 carbons here, 1 here, so I'm going to add a 2 in front of my carbons, so that doubles my whole molecule. So 2 times 1 gives me 2 here. 2 times 2 gives me 4 oxygens. I have 4 hydrogens here. I have 2 here. So what times 2 is 4? That's 2. So I add a 2 there, so that distributes to both. So 2 times 2 gives me 4. 2 times 1 gives me 2. On the left, I have 2 oxygens here, and then I have a total of 2 oxygens plus 4 means I have 6 oxygens, my X's, on the right and 2 on the left. So what times 2 gives me 6? That's 3. 4, 5, 6. So it's total on the left is total on the right.